Whoa, this is your instructor here, going to give a quick rundown on some real-world applications of trigonometry. We do, in fact, use this stuff. So, where do we use it? I'm going to give a couple of examples from my personal experience where I've actually used the Pythagorean theorem, and I think it's the sine or the cosine ratio that I actually used for cutting fence posts, and the Pythagorean theorem for dealing with the foundation of a building my parents were building. So anybody with a carpentry background or just working with lumber might have used a 3-4-5 triangle or a 6-8-10 for a larger structure. That is based on the Pythagorean theorem. So one of my favoriteest and ugliest websites, Inspectopedia, it's just a whole bunch of info as far as best practices and things to avoid and issues that might arise when you're building something or maintaining something. No formatting whatsoever. It's glorious. Just all the stuff and none of the fancy dressing up of it. So it goes into detail about the 3-4-5 and gives some examples of where it's used in carpentry. I've used it for building small shelves and stuff like that. Not quite enough to use a 3-4-5 or even a 6-8-10 triangle when you have a fairly large building. This is a picture of the laying of the foundation of my parents' shop. They live out in the middle of nowhere in BC, so they needed a place to park their vehicles and maintain them and stuff like that. So my folks knew how long they wanted this wall to be, and they knew how long they wanted this wall to be. Now, in order to make sure that this was in fact a perfect 90 degrees, what we did is we took our A and squared it, add our B and squared it, and figured out what length this should be. And we actually had a laser level here, I believe that's what that is, and we just checked that length and we adjusted, I think it was this sonotube right here. This was over 10 years ago. So we adjusted this just a little bit to make, and then lined everything up again just to make sure that we were on a clean 90. There are other ways of doing this, but this worked quite well as one extra double check. So that was the A squared plus B squared equals C squared, and make sure that's actually true to make sure we're dealing with a nice square building. More recently, I just put up a fence between my backyard and the neighbor's backyard so my dog doesn't bark at our neighbor thinking that it's his yard. He's a simple dog. He's a wonderful dog, but he's a simple dog. Now, there are little fence posts you can put up on top of these little, or fence post caps or whatever they're called. They cost a few bucks, and well, I wanted to save a few bucks. So what I ended up doing is I took a measurement of this post because it's supposed to be 4x4, but it's planed, so it's really 3 3/8. And we can basically do one of those isosceles triangle problems that you encounter in the workbook to figure out what angle I'm able to cut these posts at to make a nice pyramid shape that will shed the rain better. We have here side length, base length here of 3 3/8. Now I want to cut basically a pyramid into this. So to do that, we can use the trick of cutting the isosceles triangle in half, and it gives us two identical right angle triangles. So we've got 3 3/8 of an inch, which 3/8 is 3.375, sorry, so we got 3.375 inches. That's the whole length. I'm actually going to draw this diagram larger so it's easier to see, just not on the busy background of that photo. So I know this whole thing is 3.375 inches. And then here we just divide this guy by 2. We've got this bottom length of 1.6875 inches. Now I also took a measure of my circular saw blade, how long that was. That is 2.5 inches. That's how deep of a cut I can make, and that's what I'm really going to be cutting here, is cutting a line this way. So I know this side, I know how long of a cut I can make. With that, I can find the angle I would need to cut. So that would be this angle. We'll call this angle A. For an angle, I have my hypotenuse and my adjacent hypotenuse, that's cosine. So I know that cosine of A is equal to my adjacent, 1.6875, over my hypotenuse of 2.5. So if I take the second function of cos, I will get my angle. So second function cosine, 1.6875 divided by 2.5, 47.5 degrees. Now if I was being very precise, going all machinist on this, then yes, I would need to be very cautious with this. I'm not that good. So I'm going to give myself a bit of leeway. I used a simple 45-degree cut for this post. Now I can do that because I can adjust my circular saw blade to make a 45-degree angle cut. I set it there. And made 4 cuts. I showed the bad side because I want to be honest here. What I didn't account for is I made the mark where I started cutting a bit too low, and so the circular saw bumped up against this, so I had to use my reciprocating saw, which is not as clean of a cut. So it looks a bit janky right in here, but the rest of it is a really nice clean pyramid that comes to a nice point. And I'm just going to throw some stain on that so it's the same color as everything else, and it'll shed the rain better and it looks a bit better. So the math checks out. My ham-handedness made a bit of a flaw, but that just reminds me that I did it and is a warning to me that I need to pay more attention. Bit of pride and humility all at once. So in conclusion, we can and do use this stuff. Shop my parents built. Looks great. All the subfloor and drywall all fit properly because the building was square. It saves years off your life. And I saved a few bucks by not buying those metal fence post caps. And once again, kept my feet on the ground by doing the math carefully and then making a silly mistake with the circular saw later on. Please do share if you have examples of your own. Hope this was helpful as to maybe a little bit of motivation or some understanding as to why we and where we use this stuff.